In this video, we will be determining domain and range from the graph of a situation. Here's example 1. The graph below shows the number of students N attending a blacksmithing presentation at a local high school as a function of time. We need to answer 3 questions. A. Identify the dependent and independent variables. B. Why are the points on the graph not connected? And C. Determine the domain and range of the graph. Let's answer A. The number of attendees is a function of time. Since the number of attendees depends on the hour into the presentation, the dependent variable is N and the independent variable is T. Notice time T is on the horizontal axis and N, the number of attendees, is on the vertical axis. B. Why are the points on the graph not connected? The points on the graph are not connected because the number of student attendees is restricted to a whole number. That means we cannot have a fractional part of a student. Let's look at the domain and range of the graph. This is a discrete graph, so we will have the list of variables for the domain and the range. The domain is a set of hours into the presentation. So the domain is a set 1, 2, 3, 5, and 6. Really, it's the first coordinates of all the points in the graph. The range is a set of the numbers of attendees. So the range is 6, 11, 12, 16, and 17. These are all the second coordinates of each of the points. The lowest value is 6, the highest value is 17. And we're done. Here's example 2. A Ferris wheel has a diameter of 12 meters with the center axle 7 meters above the ground. It makes one complete rotation every 24 seconds. The graph shows the height of one of the chairs on the Ferris wheel starting at the lowest point, capital L, after one rotation. Part A says, why are the points on the graph connected? The points on the graph are connected because both height and time are not restricted to whole numbers. That means we can have a fractional part of both height and time. Part B, determine the domain and range of the graph. Notice that on the horizontal axis we have time t. On the vertical axis we have little h, or lowercase h for height. We'll distinguish this from capital H, which represents the maximum height reached by the chair. Let's look at the shadow of the graph on the horizontal axis. This will run from 0 to 24, including both 0 and 24. So the domain in set notation is the amount of time for one rotation and is represented by the set of t such that t is greater than or equal to 0 and t is less than or equal to 24, where t is a real number. We can write it in interval notation as t is an element of the closed interval from 0 to 24. Notice the square brackets because we are including the 0 and the 24. To consider range, let's look at the shadow of the graph on the vertical axis. The low point is at capital L. The high point is at capital H. So the range in set notation is the set of lowercase h's such that little h is greater than or equal to capital L and lowercase h is less than or equal to capital H, where lowercase h is a real number. It's a little simpler in interval notation. Lowercase h is an element of the closed interval from capital L to capital H. Notice the square brackets because we actually do reach those heights. Here's some practice. When an object cools over time after coming out of the oven, the graph can look like the graph below. So temperature big T of the object is a function of time little t. You may wish to hit pause here and try this on your own. Let's determine the domain and range of the graph. Let's look at the shadow of the graph on the horizontal axis. It stretches from 0 to capital C, including both. So the domain is the set of little t's such that little t is greater than or equal to 0 and little t is less than or equal to c, where t is a real number. In interval notation, this is the closed interval from 0 to c. Let's look at the shadow of the graph on the vertical axis. This runs from A to B, including both. The range is the lowest point at A to the highest point at B. So the range is a set of big T's such that big T is greater than or equal to A and big T is less than or equal to B, where T is a real number. In interval notation, this is big T is an element of the closed interval from capital A to capital B. Please proceed to the next video in this lesson, and thank you for viewing.